Hello, today I am going to explain about the heat treatment of alloys, a series of processes involving heating and cooling operation applied to a material to modify the internal structure changes in physical, mechanical and chemical properties of materials. Heat treatment methods are applied in order to strengthen the materials. The temperature and time of heating are strictly controlled as it has effect on grain size. After attaining the desired temperature, the metal is cooled at a specified rate. Stages of heat treatment process: heating a metal or alloy to a definite temperatures. Austenic, holding the material at the temperature for a sufficient period of time allow of necessary changes to occur. Cooling to obtain desired properties, example ferrite, perlite and marcentite. Mm, Principles of heating treatment: existing structure and properties of steels. While process of heating, next existing structure and properties of steels are wiped up. Next, these are three types. When it is very slow cooling, then it's called as annealing. Slow cooling, it's called as normalizing. Rapid cooling, it's called as hardening process. Next, various heating sources. Air. Greater than 850 degrees Celsius, heating is done. It leads to non-uniform heating of materials. It's a slow process. Occurs oxidation. The above problems can be controlled by using controlled temperature wrapping the components in is stainless steel foil covering the components with cast iron chips. Next, oil provides uniform and rapid heating of metal. Above 200 degrees Celsius, the heat treatment is not applicable. Silicon oil is used generally. Salt baths. Above 200 to 600 degrees temperature, this treatment is carried out. Uh, Uniform and fast heating of material reduces the oxidation. Brine solution. Next, like cooling media. Brine solution is combination of cold water plus 5 to 10 percentage of salt and NaCl or CaCl. Cold water. Water plus soluble soil, oil, air. Objectives and importance of heat treatment process: to relieve the internal stresses, refining the grain size to improve the mechanical properties, improve the machinability, hard and strengthen the material, improve electrical and mechanical properties, improve wear resistance, improve corrosion resistance. Next, heat treatment, bulk and surface or case hardening. In this, two types. Four types: annealing, normalizing, hardening, and tempering. In this annealing, we have four types: full annealing, process annealing, paradise annealing, stress relief annealing. Next, tempering. Mm, Low temperature, medium temperature, high temperature, Oz tempering, and Mar tempering. Mm, Next, we have uh, surface or case hardening, diffusion process, and thermal process. First, carburizing process, solid pack or liquid gas. Next, thermal process, flame or induction hardening. Next, diffusion process. In this, we have carburizing process, nitrating process, cyaniding, and carbon nitriding. Next, case depth. The depth or thickness obtained on the specimen after heating is called a case depth or case thickness. Surface of workpiece will be hardened. Mm, Annealing is the process. Annealing is the process of heating the metal to a suitable temperature and slow cooling inside the furnace. As a result of slow cooling, the metal acquires an equilibrium structure which causes the following properties, like to relieve the internal stresses, reduce hardness and improve ductility, to refine the grain size, to produce a definite uniform like a ductile coarse grain microstructures. Applications: these are applicable to casting, forging, presswork, and yeah. Next, we have types of annealing: full annealing, process annealing, paradise annealing. Next, in this we are learning about full annealing. The steels contains less than 0.1 percentage are heated between 723 degrees Celsius to 19 degrees Celsius. This is done to obtain outstanding structure and the temperature is maintained for a period of time. Cooling is done in furnace by decreasing the temperature from 10 degrees Celsius to 30 degrees Celsius per hour. The specimen is removed from the furnace and air cooled to a room temperature. Structure of perlite is obtained which has uniform medium coarse grain size which is soft and ductile in nature.